present here. Today we see about the topic from functions. So what is functions? The definition of function. A function takes an element from a set and maps into a unique element in another set. Then next, the function terminology. So function terminology is this is the one set or this is the another set Z. The function mapping the set R into Z. So this is called the functions. And the next, so more functions. So this is the example of functions. So this is the one set, this is the another set. So this set contains Alice, Bob, Chris, Dave, Emma. This maps into the another set A, B, C, D, F. So this is also called the class grade functions. And the next one, a string length functions. Then even more functions. So even more functions, this is the one-to-one and on-to functions. A, E, I, O, U is the one set and 1, 2, 3, 4, 5 is the another set. This is the image and this is the range. So this is the valid functions because this maps into all elements in the 1, 2 in another sets. This is not the valid function because this maps D elements is not matched in the another set. This is also not valid functions. And then next one, function arithmetic. Let f of 1 x equal to 2x and f2 of x equal to x squared. So we call the arithmetic functions of f1 plus f2 equal to f1 plus f2 of x. Next we show that the even more functions. So what is even more functions? This is the sum function and this is the not valid function. So sum function means we map into one set to another. So this is called the sum function. So not valid function means the one set is not mapping to another set is called the not valid functions. This is also called the range of the set. Then next one, function arithmetic. Let f1 of x equal to 2x, f2 of x equal to x squared. So this is the arithmetic. We combining the functions f1, f2 and we do the sums. So f1 plus f2 equal to f1 plus f2 of x equal to f1 of x plus f2 of x equal to, we substituting the value of f1 of x equal to 2x and f2 of x equal to x squared. So 2x plus x squared is the arithmetic of the functions. Next, we do the calculation is multiples. And then one-to-one functions. So one-to-one functions is also called the injective functions. So one-to-one functions, example of the diagrams, a one-to-one function, this maps into another sets. So all elements in the set is maps into another set. This is the one-to-one, this is the not one-to-one functions. So not one-to-one means the one another set is also not valid to another set. Then next one, more on one-to-one. So more on one-to-one is also so one-to-one functions is also called the more on one-to-one is also called the injective is the one-to-one functions. Then the next one is onto functions. Onto functions is also called the bijective. So bijective conditions means also satisfied one-to-one and onto conditions. So this is the example of onto functions. So the first one is onto functions. So onto functions means we map every set in the elements in the another set and also the another set maps into the initial set. So this is the onto functions, the function that is not onto. This is the example of not onto and this is the example of onto functions. Then next one, more onto. So more onto is also called the surjective. So surjective is the example of the onto functions. Note that there can be multiple use the elements in the codomain. So this is the domain and this is the codomain. So multiple elements of codomain also is match the elements of domain. So this is the more onto functions. And then next one, onto versus one-to-one. So onto versus one-to-one means are the following functions onto 1 to 1 both or neither. So we can find these are the examples of the 1 to 1 on to both 1 to 1 and on to. So first example 1 to 1 not on to. What we say that 1 to 1. So 1 to 1 is means the elements in the one set also match in the another set is called the 1 to 1. So but not on to, because the codomain of the elements is not match the all elements in the domain. So then also both 1 to 1 and on to, this is the example. Then this is, so the next one is bijection and inverse functions. So inverse function means we take any functions and mapping into inverse set. So this is the functions though are mapping to or is called the function. Then we mapping to the codomain into domain is called the inverse functions. Then next one, composition of functions. So composition of function means we take two sets is take as composite F composite G. So this is the A B set. We take the composite. So A to B is define the function F and B to C is define the function G. So we composite the function F composite G. And also the next one is useful functions. This is the useful functions of sets. So this is the floor functions. So floor functions means we take any values in the digits. So take an integer. So this is the floor function of x means take the greatest integer less than or equal to the number. So floor functions we take the less than values and a ceiling. So ceiling functions we take the greatest values of functions. So we round the functions x equal to floor function of x plus 0.5. Then next one, sample flooring and ceiling questions. So this is the sample flooring. So we flooring means the minimum values the floor. For example 1.1 is the decimal places. We take the whole integers is called the sample floor functions. And also ceiling function means the fraction numbers 1 by 2 plus 1 by 2 is taking the integers values is called the ceiling functions. The next one is factorial. So factorial means we use the formulas n factorial equal to n star of n minus 1 factorial, n minus 2 factorial, etc. So this is the factorial. Thus we replace the value of n equal to 6. We putting the formula n equal to 6. So 6 star, 5 star, 4 star, 3 star, 2 star, 1 equal to, we multiplying the all values is equal to 720. This is the factorial functions. The next one is providing function problem. So we take any two sets A and B, we make a function. So the function we use the notations union and intersection. So function of S union T equal to F of S union F of T. So function of S intersection T equal to F of S intersection F of T. So this is the providing function problem. The next one is providing function problem. Also we take the values of composition and inverse. So F composite G whole inverse equal to G inverse composite F inverse. This is the providing functions of inverse problem. Then next one is also F composite G composite of. So we take the functions and also inverse function composition. So F composite G, G composite F whole inverse of Z equal to Z. This is called the providing function problems of inverse function. This is the second equality is similar. Thank you. So finally, today we see about the topic functions and what is functions, type of functions. So type of function is 1 to 1 and on to. So 1 to 1 and on to is called the injective, bijective and surjective. And more on to functions we also see that, and floor functions, ceiling functions. Then providing function problem we also see that in this today topic. Thank you.